All right, welcome everybody. This is video number 42. This is conservation of matter, not to be confused with 41, which was conservation of mass. So, summary at the beginning, describe the conservation of matter, basically give me its definition. How is it different from the conservation of mass? Basically, why did I make a whole different video for it? And what does it allow you to determine? Okay, here we go. So when you're talking about the conservation of matter, right? So remember we said matter is anything that has mass and takes up space. Basically what you're talking about are letters. Letters, of course, meaning elements. So if you were to find sodium and chlorine on the left, no matter how you rearrange them or combine them differently, you have to find sodium and chlorine on the right. That's the conservation of matter. So, for example, let's take a look at this. We've got carbon dioxide to start with. We've got 6 molecules of it. And we also have water, H2O. So let's take a look at those elements. What do we see there? Well, we see carbon, we see oxygen, and we see hydrogen. Now, I know oxygen's written twice, so that's okay. We took that into account. So the letters I would expect to see, letters or elements that I would expect to see in the product are going to be, guess what? Carbon, oxygen, and hydrogen. Now you can't have somebody crash the party in the product that's not there in the reactant, okay? Same there, you can't leave a man behind. You can't have somebody in the reactants and have them in the product. And not have them in the product. So this is the answer to the one we were just looking at. Just shows you again that we need to have carbon, hydrogen, and oxygen represented on both sides. So let's put it into practice. So if a chemical reaction ends with the product CaCO3, which is calcium carbonate, I believe, what elements would you find in the reactants? Put me on pause, think about it. You would have calcium, carbon, and oxygen, the same 3 that you are listed there. Okay, so Harry Potter and Lavoisier, how did those go together? So I've got a YouTube clip. I want you to think about this. Does this video show conservation of matter? Why or why not?
Can you imagine the look on McGonagall's face if we were late? That was bloody brilliant.
Thank you for that assessment, Mr. Weasley. Perhaps it would be more useful if I were to transfigure Mr. Potter and yourself into a pocket watch. That way one of you might be on time.
We got lost.
Then perhaps a map. I trust you don't need one to find your seats.
We use vinegar and combined it with baking soda. Before the reaction, we measured the mass, came up with about 200 grams. We then allowed the two to mix, creating a new product. This produced carbon dioxide, sodium acetate, and water. This time we trapped the carbon dioxide and remeasured the mass of the entire product. Came up with 200 grams, did it again. So as you can see, in a chemical reaction, the number of atoms and the total mass remains the same.
Summary time. So I hope you can describe the conservation of matter. How is it different from that of the conservation of mass? And what does it allow you to determine? As always, thanks for watching, and I'll see you guys in class.